In this first piece of Chapter 6, we want to look at percent composition, which we talked about today in class a little bit, and you came up with the formula, but I just want to review that and do a couple of example problems. Percent composition is the percent of a compound made up by a given element, and this is all done by mass, not by number of atoms, but by the total mass of the compound and the mass of the elements. All of the groups today came up with the basic formula. The percent of an element is going to be the mass of the element, and this is a total mass, divided by total mass of the compound, the whole thing times 100 to make it a percentage. So we take the mass of the element, if there are more than one atom of that element, we add up all the masses of each individual atom, and then we divide that by the total mass of the compound and multiply it by 100. So let's look at two example problems. For each of these example problems, I would highly recommend that you pause, try the problem yourself, and then press play to see if you're getting it correct. So what is the percent composition of each element in potassium phosphate? So press pause here, try this, and then press play to see if you got the right answer. Okay, the first step in here is to write the formula. Potassium is K plus 1 charge. Phosphate's PO4 with a 3 minus charge. So the correct formula, K3PO4. Now when solving these, I think the easiest way to do it is set up a little table to find the total mass. You're going to have 3 potassiums, 1 phosphorus, and 4 oxygens. Potassium has a molar mass of 39.10. There are 3 of them. Phosphorus has a mass of 30.97. There's 1 of those. And oxygen has a mass of 16.00. And there are 4 of these. So in each case, you see I'm carrying these to at least 2 decimal places. So multiply these out. I get 117.3 here. And I get 64 grams for oxygen. 1 of these, so we're not going to change this number at all. Add these 3 numbers together. We get a total of 212.27. Now, if you've written out all of these steps, it becomes pretty easy to solve the problem. The percent potassium will be the mass of potassium, 117.3, divided by the total mass, 212.27, times 100. Which will come out to 55.26%. 4 significant figures, because that's the least of our original numbers. The percent phosphorus will be the mass of phosphorus, 30.97, divided by the total, 212.27, times 100. Which will be 14.59%. And the percent of oxygen will be the mass of oxygen, 64, divided by 212.27 times 100. And we get 30.15%. So it would be 55.26% potassium, 14.59% phosphorus, and 30.15% oxygen. Let's try one more example. Once again, I would recommend you try this on your own before continuing on watching the video to see the answer. So here, our formula: copper with a 2+ charge, chlorine with a -1, so it's CuCl2. So we have 1 copper, 2 chlorines. Copper has a mass of 63.55. Chlorine, 35.45 times 2, so 70.90. Total mass of the compound, 134.45. So the percent copper, 63.55 divided by 134.45 times 100. This will equal 47.27%. And the percent chlorine, 70.90 divided by 134.45 times 100. (52.73%). So this is typical of your percent composition problems. The biggest area where I think you'll have any problems is correctly writing the formula. If you see a name like this, you must write the correct formula. There's no way to correctly do the percent composition. But as long as you remember that topic from Chapter 4 and do well with that, I don't think any of you will have too much difficulty with percent composition problems.